let's fix our ideas with this very famous game called Prisoner's Dilemma. It was developed in RAND in 1950, and it models a strategic interaction where cooperation is not an equilibrium outcome, even if cooperation appears to be in the best interest of the players. And here is one of the motivating stories from Dixit and Nailboff. An orchestra conductor in the USSR was traveling by train and was looking over a musical score. A KGB officer saw this and thought that the conductor was a spy and reading secret codes. The officer arrested him and sent him to a prison cell. The conductor pleaded that it was just a Tchaikovsky violin concerto. In a while, another officer comes and says, "You'd better tell us all. We have caught Tchaikovsky and he is already talking." Those were the heights of the Cold War days, and this story is it's a symbol of the tensions between the US and USSR at the heights of Cold War. Now, here is the payoff structure. If the two accused withstand interrogation, they will each get 1 year in jail. If one implicates the other while the other holds out, the former will get away scot-free while the latter will be jailed for 10 years. If both implicate each other, then each of them will be jailed for 5 years. So here is what the payoff structure of Prisoner's Dilemma looks like. Prisoner 1 confesses or does not confess. Prisoner 2 confesses or does not confess. If both the prisoners confess, then they get 5 years of jail term. If none of them confess, then there is no way of figuring out who committed the crime or whether the crime was committed or not. So each get 1 year of jail term. If prisoner 1 confesses and prisoner 2 does not, then prisoner 1 is rewarded, he or she goes scot-free, and prisoner 2 gets a 10-year jail term. The same is true if prisoner 1 does not confess, but prisoner 2 confesses, in which case the prisoner 2 is rewarded. In this game, confess is a dominant strategy for both players, and we will come to what dominant strategy is all about. Player 1 confesses, player 2 confesses is the dominant strategy equilibrium. Why is it a dilemma? Why is it called a prisoner's dilemma? Well, the outcome that is better for both is never chosen. Which is the outcome that is better for both? Not confess, not confess. However, not confess is never chosen. What is chosen is confess, confess, in which case they get 5-year jail terms. They could have gotten scot-free, or at least they could have gotten back home within a year of detention if they had not confessed. But from the self-interest point of view, it is not in their best interest not to confess. Let's now try and understand why it is a dominant strategy. Take a look at the payoffs of prisoner 1 and prisoner 2. No matter what prisoner 2 does, prisoner 1 will always play confess and not confess. Why is that? Because -5 is greater than -10 and 0 is greater than -1. So -5 and 0 dominates -10 and -1. As a result, independent of what player 2 does, prisoner 1 is always going to confess. Similarly, independent of what prisoner 1 does, prisoner 2 will always confess. It's a symmetric game and you can easily verify that prisoner 2 will prefer -5 over -10 and 0 over -1. In other words, independent of what prisoner 1 does, prisoner 2 will always confess. Therefore, prisoner 1 will always confess and prisoner 2 will always confess independent of what others do. Therefore, this is called a dominant strategy equilibrium. Here is a slightly more complex problem. Can you find out the dominant strategy equilibrium? So here is a dominant strategy, here is a strategy of player 1 which is dominated. It is dominated strategy. Why is low a dominated strategy? Because 4 is greater than 3, 1 is greater than -1, 5 is greater than 2. In other words, medium dominates low. Player 1 will never play low independent of what player 2 does. Again, medium is dominated by high. Why is that? Because 8 is greater than 4, 2 is greater than 1, 6 is greater than 5. So player 1 will never play medium independent of what player 2 does. High dominates medium. For player 2, low is a dominated strategy. Why? Because if player 2 plays medium, then player 2 gets 4 or 5 or 1, which is at least as much as what player 2 would have got had she played low, which is 4, 3 or 0. So player 2 will never play low. Medium dominates low. You can continue in this fashion and show that high is a dominated strategy, medium dominates high for player 2, and then high is a dominated strategy for player 1. All you are left with is very low and medium, which is what the dominant strategy equilibrium is.